Our planet, a vibrant tapestry of life, is facing an escalating crisis. From space, Earth appears lush and alive, but beneath this beautiful surface, a silent emergency is unfolding. The very systems that have supported life for millennia are now under threat, and the consequences are being felt in every corner of the globe. From the parched landscapes of Africa to the arid plains of Australia, a growing number of regions are grappling with a common enemy: drought. Once fertile lands are turning to dust, and rivers that once teemed with life are now reduced to trickles or have vanished entirely. The relentless sun beats down on communities, robbing the soil of its last traces of moisture. This relentless lack of rainfall, a stark departure from the life-sustaining cycles we depend on, presents a formidable challenge to communities worldwide. The rhythm of the seasons has been disrupted, and the dependable arrival of rain is no longer guaranteed. For many, the wait for rain has become agonizing, stretching from days into weeks and sometimes even months. The anticipation of rain, once a source of hope and celebration, now brings anxiety and uncertainty. People scan the skies for any sign of relief, but the clouds often pass by without delivering a single drop. Water, the elixir of life, is the very foundation upon which our societies are built. It is more than just a resource, it is the thread that weaves together every aspect of our existence. Without it, civilizations falter and the dreams of future generations are put at risk. It nourishes our crops, quenches our thirst, and sustains the intricate web of ecosystems that blanket our planet. Every living thing, from the smallest insect to the largest mammal, depends on water's life-giving properties. Forests thrive, rivers flow, and fields flourish, all because of the regular gift of rain. When rain becomes a rare and precious commodity, the consequences are far-reaching and devastating. Reservoirs shrink, wells run dry, and the very fabric of daily life begins to unravel. The scarcity of water forces people to make impossible choices between drinking, cooking, and growing food. Crops wither and die, leaving farmers struggling to feed their families and communities facing the specter of famine. The loss of harvests means not only hunger but also economic hardship, as livelihoods are destroyed and entire regions are plunged into uncertainty. Water sources dwindle, forcing families to embark on arduous journeys in search of this precious resource. In many places, children miss school to help their families collect water, and women walk for hours each day, carrying heavy loads just to meet basic needs. The delicate balance of nature is disrupted, pushing ecosystems to the brink of collapse. Wildlife struggles to survive as habitats shrink and food becomes scarce. The loss of water ripples through the food chain, threatening the survival of countless species. The urgency of this situation cannot be overstated. News headlines warn of impending disaster, and scientists issue dire predictions about the future. The clock is ticking, and the window for action is rapidly closing. As the global population continues to grow and the impacts of climate change intensify, the need for reliable access to water becomes ever more paramount. Urban centers, once immune to water shortages, now face rationing and restrictions, while rural communities are left even more vulnerable. Climate change is amplifying the crisis, altering weather patterns and making droughts more frequent and severe. The challenge is not just local, but global, demanding cooperation and innovation on an unprecedented scale. In the face of this growing crisis, humanity has long sought ways to influence the very forces of nature, to coax rain from the heavens and quench the thirst of a parched planet. From ancient rituals to cutting-edge science, our quest for rain is a testament to our resilience and ingenuity. But as the stakes grow higher, the need for effective solutions has never been more urgent. For centuries, humans have gazed at the sky, marveling at the power and mystery of the weather. The sky has always been a source of fascination, hope, and sometimes fear. Ancient civilizations built myths around the rain, worshipped deities they believed controlled the clouds, and performed elaborate rituals in hopes of coaxing water from the heavens. The unpredictability of rain shaped the rise and fall of empires, determined the fate of crops, and influenced the very course of human history. While our ancestors could only observe and revere, today's scientists are venturing into the realm of weather modification, attempting to influence the very elements that shape our world. With the help of cutting-edge technology and a deeper understanding of atmospheric science, they are no longer passive spectators. Instead, they are becoming active participants in the age-old dance between earth and sky, seeking to harness the forces of nature for the benefit of humanity. At the heart of this endeavor lies a technique known as cloud seeding. This process, once the stuff of science fiction, is now a reality in many parts of the world. Cloud seeding is a method that aims to encourage rainfall by introducing specific substances into clouds, essentially giving nature a helping hand when conditions are just right. Imagine, if you will, a fleet of aircraft soaring high above the Earth, their mission to unlock the secrets of the clouds. These planes glide through the sky, sometimes in formation, sometimes alone, carrying with them the hopes of farmers, city planners, and entire communities who depend on rain for survival. These are not ordinary planes but flying laboratories equipped with sophisticated instruments and a payload that holds the promise of rain. Inside, teams of technicians and scientists monitor every detail from wind speed to humidity, ensuring that each mission is as precise as possible. The technology on board is the result of decades of research and innovation designed to maximize the chances of success. Cloud seeding involves introducing tiny particles, often silver iodide, into clouds that are already laden with moisture. These particles are carefully chosen for their ability to mimic the structure of natural ice crystals, making them ideal for jump-starting the process of precipitation. These particles act as condensation nuclei, providing a surface for water vapor to cling to and form raindrops. As more and more droplets gather, they eventually become heavy enough to fall to the earth as rain, nourishing the land below. It's like giving a gentle nudge to a cloud that's already brimming with the potential for rain. The process doesn't create rain out of thin air, but rather helps unlock the moisture that's already present, turning possibility into reality. The process is remarkably complex, requiring a deep understanding of atmospheric science, weather patterns, and cloud dynamics. Teams of experts analyze vast amounts of data, using advanced computer models to predict when and where seeding will be most effective. Every mission is a blend of science, technology, and a touch of intuition. Scientists carefully select clouds that are ripe for seeding, analyzing their temperature, humidity, and wind conditions to maximize the chances of success. It is a delicate balance. Too little moisture and the effort is wasted, too much, and the results can be unpredictable. In this modern quest to make rain, we see the enduring human desire to understand, adapt to, and ultimately shape the world around us. The allure of artificial rain has captivated nations across the globe, inspiring a new era of weather modification that blurs the line between science fiction and reality. As climate change intensifies and water scarcity becomes a pressing concern, countries are increasingly turning to innovative solutions to secure their future. Cloud seeding, once a niche scientific experiment, has now become a global phenomenon, with governments and researchers racing to harness the power of the skies. This quest for control over the weather has prompted ambitious experiments from the snow-capped mountains of America to the sun-baked deserts of the Middle East. Each region faces its own unique challenges, but the goal remains the same: to coax precious rainfall from stubborn clouds and bring relief to parched lands. China, a nation grappling with both sprawling megacities and vast arid regions, has emerged as a leading proponent of cloud seeding. With a population exceeding 1.4 billion and a rapidly growing demand for water, the stakes are high. The Chinese government has made weather modification a national priority, investing billions of dollars into research, technology, and large-scale operations. From the icy heights of the Tibetan Plateau, where Asia's great rivers are born, to the fertile but drought-prone North China Plain, China has deployed a vast network of cloud seeding aircraft and ground-based generators. These efforts are designed to enhance rainfall, combat persistent droughts, and even reduce the impact of devastating sandstorms that threaten agriculture and urban life alike. The scale of these efforts is staggering. Chinese officials claim that their cloud seeding programs have increased rainfall by billions of cubic meters each year, helping to fill reservoirs, irrigate crops, and stabilize water supplies for millions. Satellite imagery and rainfall data are meticulously analyzed to measure the impact, and the results have fueled even greater ambitions for the future. In the United Arab Emirates, a nation synonymous with scorching deserts and relentless sunshine, cloud seeding has become an integral part of the country's water security strategy. With less than 100 millimeters of rainfall annually and rapidly growing cities, the UAE faces one of the world's most acute water shortages. Faced with limited freshwater resources, the UAE has turned to the skies, employing a fleet of specially equipped aircraft to seed clouds and replenish its dwindling water reserves. Teams of meteorologists and pilots work around the clock, monitoring weather patterns and launching missions at a moment's notice whenever conditions are favorable. The hope is to transform the arid landscape, making life more sustainable for future generations. The United States, too, has a long and storied history of experimenting with cloud seeding, with programs dating back to the 1940s. Early pioneers saw the potential to tame the weather, and over the decades, American scientists and engineers have refined their techniques, learning from both successes and failures. From the drought-stricken plains of Texas, where every drop of rain is precious, to the snow-capped peaks of the Rocky Mountains, cloud seeding has been employed to enhance precipitation, replenish vital reservoirs, and even suppress destructive hailstorms. Today, as climate extremes become more common, the United States continues to explore new frontiers in weather modification, seeking to secure water for agriculture, cities, and the environment alike. The quest to control the weather, like any ambitious endeavor, is fraught with both triumphs and challenges, and often stirs passionate debate. While proponents of cloud seeding point to promising results and the potential to alleviate water scarcity, critics raise concerns about its effectiveness, unintended consequences, and ethical implications. Success stories abound, with proponents citing increased rainfall, replenished reservoirs, and even the prevention of damaging hailstorms as evidence of cloud seeding's potential. However, the science remains complex and often inconclusive, leaving many questions unanswered. Critics argue that attributing increased rainfall solely to cloud seeding is difficult, as natural variations in weather patterns can mask its true impact. They also raise concerns about the long-term environmental consequences of introducing foreign substances into the atmosphere. The use of silver iodide in particular has drawn scrutiny, with some studies suggesting potential negative impacts on aquatic ecosystems and human health. While the amounts used in cloud seeding are generally considered safe, the long-term cumulative effects remain a subject of ongoing debate. Section 5. Technological Horizons, Drones, AI, and the Future of Weather Control.